Hello, good evening, friend. Today I'm going to explain one more important topic of the surface chemistry, and the topic is characteristics of physisorption. Okay, so we understand in the last video lecture that there are two type of adsorption are there: physisorption and chemisorption. Physisorption means physical adsorption, in which that is the there is a bond formed between the adsorbate, and adsorbent is the van der Waals force of attraction, while the in the chemical adsorption we seen that there is the bond is formed between the adsorbate, and adsorbent is the chemical bond such as either covalent bond or the ionic bond. Now the another heading is important heading, which is asking that is what is the characteristics of the physisorption. So physical adsorption, the first there are so many characteristics, but I am going to deal with one by one. First one is the lack of specificity. Lack of specificity means what? As the bond form is van der Waals force of attraction, van der Waals force of attraction, which is universal, So it does not, so any preference, to any particular gas, so it is not specific, okay. So I hope this point will be clear. That is, when you are going for van der Waals forces, they are the universal forces. So universal forces means that is no specificity. Okay, so this was your first answer. Now the second point is, when you are going for the second point, nature of adsorbent. Second point is nature of adsorbate. Okay, so nature, it's highly depends on the nature of adsorbate, because this is the bond is formed by processes takes place as a bond formation of van der Waals forces, and we know that is the as the I am writing here as van der Waals forces, are stronger near critical temperature, critical temperature. So so easily liquefiable gases gets adsorbed readily, now you see that is higher the critical temperature, that is proportional is easy to liquefy, proportional to more adsorption. Why more adsorption? As van der Waals forces is high, van der Waals forces is high. I hope the point will be clear, because I am going very point wise, very basic point I am explaining here, so you will be able to understand the point also. Now for example, if you are taking for example, suppose I am taking that is SO2, I am taking CH4 and H2. So here is critical temperature CT. I am writing critical temperature of this critical temperature. So critical temperature of SO2, it is 630 Kelvin, and it is having the 190 Kelvin, and methane is having 33 Kelvin. So this is the easily liquefiable, easily liquefiable, so more readily absorb, more readily adsorb. So more the critical temperature, more the critical temperature, easy to liquefy, and more will be the adsorption. So this was the second point. Now let us go for the few more points of the characteristics of the physical adsorption. And when you are going the next point, that is reversibility. The next point is, that is third point, it is the reversibility in nature. Means this is the reversible, means what? Physisorption is reversible in nature, is reversible in nature. Now why it is reversible in nature, that we have to explain. As it is depends on temperature, that is exothermic process, which we explain in previous video, exothermic temperature and pressure. And as it is depending on the temperature and pressure, so the process is exothermic. Now this can be more understand also, that is suppose here is adsorbent plus adsorbent is there, adsorbent. Now reversibly what they are forming, that is the adsorption process is taking place plus heat, okay, that is exothermic. Now what you can do, if you are removing this, so what will happen, it will be the forward direction, and if you are not removing it, heat is increasing, so according to Lear principle, it will be the reverse direction, okay. And now that is, if you see, it is the process is exothermic, okay, the process is exothermic. So this is the exothermic. So high absorption, high rate of absorption, high rate of absorption at low temperature, okay. Now the fourth point I'm going to explain, fourth point, surface area of the adsorbent, okay, surface area of the adsorbent, okay. So surface area of the adsorbent means what? It will increase with the increase in the surface area. That is what? Adsorption increases with increase in surface area, surface area means more space is there to get absorbed, Now when you are going, that is, so finally divided adsorbent has more adsorption rate, okay. That can be explained on the basis of, suppose this is the finely divided metal, okay. So finely divided metal, so so many sides are there compared to these, so more surface area here and more surface area, you know, uh, and less surface area. Okay, this is finely divided metal, so more surface area, so that is more rate of adsorption, more rate of adsorption. Here is more rate of adsorption, and here is what, less rate of adsorption. Now we have to explain the last point, enthalpy of adsorption. The fifth number point is there, enthalpy of adsorption. Enthalpy of adsorption. Now we know the process is what, that is the, in this process what kind of bond is getting formed. In this process only the weak van der Waals forces are getting formed. Okay, so weak van der Waals forces are getting formed, it means the enthalpy of adsorption will be very less, since in the process weak van der Waals forces exist, so that enthalpy of adsorption is, enthalpy of adsorption is very low. How much? That is, it is about, about 20 to 40 kilojoule, kilojoule per mole. So this is all about the adsorption, characteristic of the adsorption. So there are 5 characteristics which explain, that is firstly lack of specificity, because van der Waals forces are universal, so this is not specific for the particular gases. And second is nature of adsorbent. Nature of adsorbent means the, van der Waals forces are high at the critical temperature, near to critical temperature. So greater the critical temperature, easy to liquefy the gases, and more will be the adsorption rate. Now next one is the reversibility. Okay, now the adsorption is depending on the pressure and temperature. So any of the value if you are changing, it can be reversed. If it is exothermic process, so if you are increasing the temperature, so rate of adsorption will be reverse direction. And if you are removing desorption, if you are doing desorption also, so what will happen, rate of adsorption will increase forward direction according to Le Chatelier principle. Now the next one is the surface area. Surface area means greater the surface area, more will be the adsorption. Okay, so finely divided metal will have the more adsorption rate compared to the normal metal. Now enthalpy of adsorption. Since we know that in this process the existing force is the van der Waals force, a weak van der Waals force of attraction, so enthalpy of adsorption will always be very less. Okay, that is, in this process 20 to 40 kilojoule per mole enthalpy of adsorption is there. Thank you so much for watching, friend.